Hello and welcome back. So in this video we are going to solve two more questions of sequences and patterns from past paper for O levels, and this question is taken from June 2020 paper 1 variant 2, and this is question 17 of that paper. It states here are first four terms of a number sequence. T1 is 1 square plus 3 is equals 4, T2 is 2 square plus 8 equals 12, T3 is 3 square plus 13 it equals 22, T4 is 4 square plus 18 it equals 34. So as we observe, like this sequence work as first we square the uh, term number and then we are adding a number to it, which is actually a linear sequence. We first added 5 to 3 which became 8, then we added 5 to 8 it became 13, so we are actually increasing it by 5. In a part it said find t5, so in order to find the t5 we will first square the term number, like it will become 5 square, and then we are going to add a number which will be 5 more than 18, so it will be 23. 5 square plus 23, and that shall become 25 plus 23 it equals 48. So T5 is 48. In B part it stated find an expression in terms of n for Tn. So we are to find the expression for Tn, like it is the nth term formula for that sequence. And because it is Tn, we know we first square the term number, so it will become n square, and then we add a term to it. And in order to find that term, we observe that it is a linear sequence, 3, 8, 13, 18. So we will figure out the nth term for this sequence, 3, 8, 13, 18, as the common difference is 5. So the nth term formula for this linear sequence, we know it will become a plus d times n minus 1, where a is the first term, which is 3 over here. The common difference is 5. So 3 plus 5 times n minus 1, and when we simplify, it shall become 5n minus 2. So this is the term being added to n square, 5n minus 2. So this is the Tn for the given sequence, n square plus 5n minus 2. That is the nth term of this sequence. Let us move to the next question. It is a question which is from paper from November 2020, paper 1, variant 1, and that is question number 18 of that paper. Let us start it from the very beginning. It states some numbers are arranged in rows. Each row contains one more number than the previous row. The number in each row are two more than the numbers in the previous row. So as we see in row 1 there are two numbers and both are 3. In row 2 there are three numbers and both are 5, like two more than the previous number. In row 3 there are total 4 numbers and that is again two more than the previous number. And in row there are 9, but they are like repeated 5 times. So in A part it said complete the row 5. We know it will be a number 2 more than 9, so it will be 11, and it will be repeated 6 times because the number of numbers is increasing by 1 every time. So it is 11 repeated 6 times. So that is the row 5. Then it said write down an expression in terms of n for each number in row n. So because we have to find the expression for number in row n, we see the number in row 1 was 3, the number in row 2 was 5, the number in row 3 was 7, the number in row 4 was 9. So we can observe that it is basically a linear sequence with a common difference of 2. So in order to figure out its nth term formula, it will be a plus d times n minus 1, which becomes 3 plus 2 times n minus 1, and when we simplify it shall become 2n plus 1. So 2n plus 1 will be the number in row n. Then it said, write down an expression in terms of n for the number of numbers in row n. Like as we said, the number of numbers in row 1 was 2, the number of numbers in row 2 was 3, the number of numbers in row 3 was 4. So it is basically one more than the row number. So it is row n, so the number of numbers will be n plus 1. So the number of numbers in row n is n plus 1. Then it said in D part, write down an expression in terms of n for the sum of numbers in row n. Like we know in row n, like each number is 2n plus 1, and this number is repeated n plus 1 times, because we know the number of numbers in row n is n plus 1. So if it is repeated n plus 1 times, the same number is repeated n plus 1 times. When we add these numbers, we shall actually multiply n plus 1 times 2n plus 1. So that shall become the expression for the sum of numbers in the row n. And we can expand it as well, but because it is worth 1 mark only, so we can keep it as it is. So these were two questions. They involved the patterns, and in next video we are going to deal with some questions which involve diagrams.